All right, this video is about rewriting between two different forms. So we're going to be converting between rational exponent notation and radical notation. So sometimes it just helps you to convert it to a different form to simplify it a little bit better. We're also going to look at simplifying radicals. All right, so the examples that I'm going to look at here, when we convert between the two forms, is I'm going to kind of use this whole little visual right here about roots being at the bottom of trees. All right, so we know that roots are at the bottom of trees. So we're going to use that to kind of help us when we rewrite things. All right, so first though, I want you to look at this initial rule. This little n right here is called an index or a root. All right, so like if I were to, have a number there, right, I would read this cube root, fifth root. Okay, so that's why I kind of call it a root sometimes, but it's really the index. All right, so whatever that number is, it's a root, right? So nth root, fifth root, cubed root. And where are roots? Roots are at the bottom of trees. All right, so notice that this n became the denominator of this fraction. Now, the only reason why this is a 1 is because this a could technically be raised to the first power and nothing happened, right? So it'd be like 1 over n. Now, so when we look at this example over here, we have the cube root of 11. Well, that's really like the cube root of 11 to the first power. So this is my root. Roots are at the bottom of trees, so this would be rewritten as 11 to the 1/3 power. Now, I do want you to realize that this 1/3 is an exponent. I'm not saying 11 to the and 1/3. Like, that's not right. All right, it has to be elevated. It is an exponent or power. Okay, now for this next one, you have the fifth root of x to the third power. Again, the 5 is the root. Roots are at the bottom of trees. So we would make this or rewrite it as x to the 3/5. All right, so it's all about placement of your numbers. All right, so in a prior video, I think I looked at something like if you had x to the 1/2 power, that was the same thing as the square root of x. All right, so that's where this next property comes in. So this time we're going from rational notation, which means we start off with a fractional exponent, and we're going to convert it to radical notation. But we're still going to use this whole, roots are at the bottom of trees hint. All right, so here, you know, they kind of separate it out here, which makes it a little bit more confusing for me. I kind of go straight from this first example, right? The first piece all the way to the back, but sometimes it does help to break it apart too, and we'll see that later as well. So here the n is the denominator, right? Bottom of trees. So the n is my root or my index. So notice that the n became the root. And then the a to the m power stayed a to the m power. All right, so that part stayed. So when we look at this example, 6 to the 1/3 power, 3 is my root because it's at the bottom of the tree, right? Denominator. So I'm going to say the cubed root of 6 to the first power. Well, anything to the first power is just itself, so really it would just be the cube root of 6. All right, if you put the 1 there, it's not a big deal, but that's not the most simplified. So it's better to have just the cube root of 6. All right, so then the second example, the root is the 2. So we have the square root of x to the 5th power. Now, when have we ever had a little baby 2 there, when we've talked about square roots? Never, right? Okay, and that's because square roots are kind of one of the most common roots, right? So, I mean, there's a button on your calculator for that square root, right? So, the only time that they change that number is if it's something other than 2. It's kind of an understood 2. All right, so we don't really need to write that little baby 2 there. We can drop it and just say the square root of x to the 5th power. All right, sometimes you'll see parentheses, sometimes you won't. So, sometimes they'll do this, but it doesn't necessarily have to be there. All right. So that's converting between the two forms. So you have some practice problems to do as well, but I wanted to give you a couple of extra examples before you do that, all right? So This one is in rational exponent notation. So if I convert that to radical notation, just as a quick review again, this is my root because it's at the denominator. So I'm going to have the square root of 36 to the third power. All right, but do I need the square root? No. So I could drop that little baby 2 and just put the square root of 36 cubed. Now, what is the square root of 36? 6. So 6 cubed is what? 36 times 6, I don't know. So 6 to the third power. So 216 would be our final answer. Okay, now if you are rewriting it in radical notation, then I would be perfectly fine with you leaving it like this because that is radical notation, but the full simplified answer would be 216. All right, so same thing with this next one. We know the square root of 25 is 5. Like we could legit go ahead and do that and say, okay, well, 5 to the 5th power is what? Okay, but to rewrite it in rational exponent notation, I want to remind you that this is really a 2, right? Because square root of 25. So this would be the same thing as 25 to the 5 halves power. All right? And so we could just leave it like that. Or you could do the math and actually do it. All right? So 25 2 raised to the 5 halves power is 3125. All right, so that's the most simplified version. So this is rewriting it in rational exponent notation. So, and then this is actually simplifying it all the way out. All right, so we also have simplifying radicals without a calculator. So this is something that you should have actually learned in Algebra 1, but just in case, because it is going to creep up, I want to remind you. And so what I do is I always divide by 2, and then I divide by 3, and then I divide by, until I can't divide by anything anymore, okay? So I always start off with small numbers, and then I kind of work my way through. Some teachers will teach it like, well, what's the biggest, perfect square that will divide into that number? And that's all fine and good if you can see it, okay? But sometimes we don't think about those bigger numbers. So for me, it's easier to just kind of start off small and then teach it where it's very consistent. You're doing the same thing every time you see these types of problems. All right, now if you had a calculator, you could just put it in your calculator, right? Okay, but not all calculators reduce your fraction for you. All right, so to reduce this by hand, I start off by dividing by 2 if I can. All right, so this would be the square root of 2 times the square root of 12 because 2 times 12 is 24. And as I go, I cross out the original because I don't want to get confused. All right, so then I have square root of 12 would be the square root of 2 times the square root of 6. And then cross out the 12. And then 6 would be the square root of 2 and the square root of 3. All right, so this is where my cheesy analogy comes in. All right, so here I kind of do square roots like a whole marriage or couple scenario. All right, so when you get married, you want to move out of the house, right? You don't want to live with mom and dad forever. Okay, so but you can't get married unless you're a perfect pair. So for this analogy, a perfect pair is not a 2 and a 3, it's a 2 and a 2, or a 5 and a 5, or a 6 and a 6, or something like that. It has to be a perfect pair. So when you get married, you move out of the house. But if you don't have a perfect pair, then you're stuck at home. So when I'm talking about the house and I'm talking about home, I'm talking about the radical. Okay, you're under the radical. And if you get to move out of the house, then you get married and you become Mr. and Mrs. whatever. So if you're a perfect pair of 2s, you come out of the house as Mr. and Mrs. 2 one time, not 2. Like it wouldn't make sense. Like I'm Hirsch, right? So when my husband and I got married, we didn't get pronounced. I now pronounce you Mr. and Mrs. Hirsch. Like that's weird. It was Mr. and Mrs. Hirsch one time. Okay, so kind of use that analogy to kind of help go through these problems. All right, so if I looked at this original problem that I have here, the square root of 24, I have a perfect pair of 2's. So that's Mr. and Mrs. 2. They get married. They get to come out of the house, right? So Mr. and Mrs. 2 times. All right. Now, the square root of 2 and the square root of 3, do they get to get married and come out of the house? No. So they're still stuck in the house. So all of these pieces get multiplied. So I have 2 times the square root of 6. So if you have more than one thing out of the house, they get multiplied. If you have more than one thing under the house, they get multiplied. All right. So next example, the square root of 27. Here, we can't divide by 2. So now I got to try 3, and I just keep going. All right, so can 27 be divided by 3? Yes, 3. So it'll be the square root of 3 times the square root of 9, because 3 times 9 is 27. Well, the square root of 9 is the square root of 3 times the square root of 3. So now I'm ready to pair things up. So I would have Mr. and Mrs. 3, right? They get to come out of the house, and then 4 babies stuck at home, so square root of 3, and then that's it. All right, so then a little bit bigger of a number with the square root of 96, we would have, that's an even number, so I could divide by 2, so I would have 2 times 48. 48 would be 2 times 24, 2 times 12, 2 times 6, 2 times 3. All right, so I'm breaking it down until I can't break it down anymore, basically until you just have nothing but prime numbers. All right, so now I'm ready to kind of start grouping. All right, so I have a perfect pair, Mr. and Mrs. 2, a perfect pair, Mr. and Mrs. 2, and then these are stuck at home, right? So if you have more than one thing out of the house, they get multiplied. So 2 times 2 is 4. And if you have more than one thing in the house, they get multiplied. So the square root of 6. So 4 square roots of 6. All right. Now the last problem is one that's going to throw some people off. So I'm going to start off with this process, and then I'm going to kind of talk you through it like for real. Okay. So if we look at this problem, because I just taught you this, divide by 2 and everything like that, you would probably start this off as the square root of 2 times the square root of 32, right? Square root of 2 times the square root of 16. Now at this point, some of y'all are going to say, oh, the square root of 4 times the square root of 4. And that's okay. You can do that. All right. But then this is what some of y'all are going to do. You're going to go, oh, square root of 2, square root of 2, square root of 2, square root of 2. Okay. However, I want to caution you. All right. You don't ever want to break up a perfect pair, right? So if I get to this point and I see those 4s because maybe my mind went there, then go ahead and let it be a perfect pair. There's no reason to break up a perfect marriage, right? So we go ahead and we leave it alone. All right, so then I have my perfect pair of 4s and I have my perfect pair of 2s. Well, what is 4 times 2? 8. All right, and I could have kept this 16 going. I could have said 2 times 8, 2 times 4, 2 times 2, and I would have just had more perfect pairs, and I still would have gotten to the end and gotten 8. All right, but I want to kind of make sure you think about this a little bit. If you hadn't had this lesson and I just said, hey, what's the square root of 64? You'd probably go 8. You know what I mean? Like it's something that you already know. So just kind of remember that some of these are just basic radicals that you're already used to. Okay. Also, I don't want you to assume that every single radical simplifies. If I gave you the square root of 21, for example, well, the square root of 21, 7 times 3 is 21, but do either of those radicals reduce out anymore? No. So the square root of 21 would not reduce, and it would just stay the square root of 21. Okay, so they're not always going to simplify. All right, but these ones do. All right, so using what we just talked about there, and by doing this math, I actually already previewed the next couple of properties because I said, if you have more than one thing out of the house, they get multiplied. If you have more than one thing in the house, they get multiplied, right? So these properties, this first one is called the product rule. Again, notice that if it has the same index, right? If it's the square root of something times the square root of something, or the fourth root times the fourth root, fifth root times the fifth root, cube root times the cube root, then you can use this property. I cannot use this property if I had the square root of 5 times the cube root of 7. Like, I can't do that. All right. So, but here, as long as that index is the same, if you have more than one thing out or in the house, then what do? They get multiplied. So for the example, it would just be the square root of 10x. And make sure that they're both under the radical. All right. For the quotient property, same thing. Make sure that your indexes or your roots are the same. All right. So if I have the square root of 10 divided by the square root of 2, those are the same root, the same index, right? So if that's the case, I can go ahead and just divide to get 5, but make sure it's the square root of 5, not just plain 5. All right. Now the rules can go either direction, so it just depends on what makes it the most, the easiest, I guess, to simplify. All right. So an example of that would be this first example. All right. It's already kind of pushed together, right? But it may actually be easier to break it apart because the square root of 121 over the square root of 49 is easier to simplify. What is the square root of 121? 11. What is the square root of 49? 7. Can that reduce? No. Okay, so it was easier for that one to just kind of break it apart and then do the math individually. All right, and some of y'all won't have to see this step. Some of y'all are just going to do it, square root of 121, square root of 149, and 49 and get the same answer. All right, so the next example, you have the square root of 25, p to the 12, m to the 18. This one is an example of terms that are being multiplied under the radical. And in this case, it's easier to kind of bust it apart. So think about what you have here. All right. So if I have this and I break it apart, I have the square root of 25, the square root of p to the 12, and the square root of m to the 18, right? All right, well, what is the square root of 25? 5. And then we've got to be careful with these next ones. All right, don't forget that the square root is really like there's this baby 2 here, right? All right, so really that would be p to the 12 halves, m to the 18 halves. All right, so, and then we would just reduce our fractions. So our final answer would be 5p to the 6, m to the 9. And then nothing else combines because you have different terms. Okay, we have our numerical term, p, m. All right. So then this next example, you have a cube root. So we have the cube root of 8, the cube root of x to the 21, and the cube root of m to the 9. So we're going to break that down. What is the cube root of 8? Now, like, I know it's 2, but if you didn't know, then you'd use your calculator. You would say 3 second caret. That's how you get the cube root of 8. 3 second caret. And it's 2. All right, so I know it's 2. And then I would have x to the 21 thirds, and then m to the 9 thirds. All right, so that would give me 2x to the 7, m to the 3. All right, so pay attention because sometimes we get square root happy and we forget to pay attention to whether or not the root is actually a square root or cube root, fourth root, fifth root, whatever it happens to be. All right, so in this last example, we would have the square root of 32, the square root of p to the 11, and the square root of m to the 17. And this one is crazy, okay? There's a lot going on in this problem. All right, so I'm gonna do a lot of things by hand. All right, so first of all, we have to reduce or simplify the square root of 32. All right, and so this is what we just learned, where we would have, square root of 2 times the square root of 16. 16 would break down as 4 and 4, or we could do 2 and 8, 2 and 4, and so on. But the square root of 4 and 4 makes it a little bit quicker. All right, so I have Mr. and Mrs. 4, square roots of 2. All right, so I have 4 square roots of 2. That's the first term. Now I need to do the second term. Now remember, this is like a little baby 2, right? So I have P, I'm going to change my color here, P to the 11 halves. So I'm just going to focus on that. So this is where people kind of get a little confused. All right, so what I do is I try to think, okay, if I were to divide that, how many times does 2 go into the 11? Because that's how many get to come out of the house. That's how many like perfect pairs there are, right? Without actually writing down 11 P's. Now, if you needed to, you could write 11 P's and then see how many perfect pairs there are. But 2 goes into 11 5 times. So that means I have P to the 5. There's 5 perfect pairs. But then how many would be left over? 1, because 5 perfect pairs would give you the 10, and then there's 1 left over. So there's a P that's still left in the house. All right. Now, if I look at the M, then I have M to the 17 halves. Well, how many perfect pairs are there? How many 2's go into 17? Well, 8, right? So there would be 8 perfect pairs. So the perfect pairs get to come out of the house, out of the radical, but then how many are left over? Well, there's only 1 left over. So there would be a square root of M. All right. So you're not going to have very many of these in our class because most of ours are going to be like the whole numbers, the ones that work out really pretty. But if you were to be taking an honors class or take some more advanced classes, then you would see a lot more like this last example. All right. So now that I have all of these terms, I need to see what all can go together. Okay. So I'm going to have a 4 P to the 5, M to the 8 times the square root of 2PM. And that's my final answer. Okay? And be careful with this M to the 8. We don't want to think that that's the root. Like we don't want to think it's an 8th root. So it may actually be a little more helpful to put this in parentheses just to make sure. All right, so that is converting between radicals, all right, as well as simplifying radicals.